Imagine you are playing a video game where pressing a button once makes your player jump, not continuously, just one jump. How does the system remember you already pressed that button? That's where sequential logic comes in. Sequential logic is how digital systems remember things, unlike simple logic circuits that only care about what's happening now. That is combinational logic. Sequential logic remembers what happened before. To clearly understand sequential logic, we need to first know the difference between combinational logic and sequential logic. Combinational logic is like a calculator whose output depends only on what you type right now, while sequential logic is like a scoreboard. It remembers the previous score and updates it with new inputs. In electronics, we use special circuits called flip-flops to remember one bit of information, either a 0 or a 1. And this is where the concept of SRO flip-flop comes in. That's the set and reset flip-flop, where the set makes the output 1, the reset makes the output 0. So if neither is pressed, it remembers what happened before. Alright, and you can see the LED demonstration of the SRO flip-flop, which show us how memory in circuits works. Other common flip-flops are the D flip-flop, that is data that stores whatever data input says when clock ticks. We also have the JK flip-flop, that is like the set and reset flip-flop, but it's smarter because it avoids invalid states. Then we have the T flip-flop, toggle, that flips states every time you trigger. So here are some of the examples where sequential logic is used. It's used in traffic lights that change in sequence, in washing machines that run in time steps, in digital clocks counting seconds, and in keypad locks remembering previous key presses. Each of these uses flip-flops and sequential logic to control what happens next based on what happened before. In embedded systems, we use microcontrollers, that is tiny computers that controls things like robots, fans, or smartwatches. Inside these microcontrollers are sequential logic circuits that store data, control timing, and make decisions based on past events. When you press a button to turn on a fan or an LED, the system remembers it's on even after you release the button. That's sequential logic. Your smartwatch counting steps uses memory registers built with flip-flops. Your Arduino coding using if and state variables behaves just like sequential logic. Now, press the button once, LED toggles on, and when we press the button again, LED toggles off. This is a software version of T flip-flop inside your embedded. Sequential logic is what gives machine memory. It's the foundation of microcontrollers, computers, and smart devices. Without it, your embedded system would forget everything instantly. Thanks for watching. Don't forget to like, share, and subscribe for more awesome embedded systems lesson. Don't forget to like and subscribe to encourage the growth of this channel. See you in the next video. Bye.